This is the question from IPM Indore 2023 paper QA section. It says that there are A1, A2 and A3, these three distinct real numbers, and they are in geometric progression. So if the equation A1x square to A2x plus A3 and B1x square to B2x plus B3, they have a common root. So if these two equations have one common root, then which of the following is true? So we are given two quadratic equations and they have one common root. So we have to use this information. Now, first information that is given is these three numbers are in GP. So let us use this information. So I can say A2 is A1R and A3 is A1 R square or A2R. So this can be written both ways. So that is the information of the first line that we have used, that these three numbers are in GP. Now we can use this information in the first quadratic equation because this equation has A1, A2 and A3 as the coefficients. So A1 is A1x square to A2. In place of A2, I can write A1R. So 2A1RX. And then in place of A3, we can write A1R square. So that is 0. So since A1 is common, so we can remove that. So x square plus 2RX plus R square, that is 0. So x plus R whole square is 0. So this will give us x equal to minus R. X equal to minus R, that is only one root of this quadratic equation, first equation. So since both the both the equations have one common root, that means the first equation which has only one root, that root has to be common. So in the second equation, if I replace x with minus R, then that should satisfy the equation. That means x equal to minus R should make this expression 0. So I will replace x with minus R. B1x square plus 2B2x plus B3. This is the quadratic equation. I will replace all the x's with minus R. So B1R square minus 2B2R plus B3. That is 0. So this is where we get. Now, from this information, we have used everything that is given to us. From this information, we need to conclude one of these options. So can we say anything about B1, B2 and B3 from this? Since we don't know the value of R, we cannot remove this R from this equation. So first two options will be difficult to conclude from this information, from this equation, because R cannot be removed. And if R cannot be removed, we cannot conclude first two options which do not have any R. Next two options have R as well as, B as well as A. So in this equation, we only have B, but we also have R. So that means R can be replaced with something which has A. So we can go to this point. So I can say that R is A2 by A1 from here. So if I replace minus 2B2, R can be replaced with A2 by A1. And we have B3 here. Then R square can be replaced with A3 by A1 because A3 is A1 R square. So R square can be replaced with A3 by A1. So this becomes the new equation. And now this equation does not have any R, but it has some B's and some A's. So let us see what can be done from here. Okay. So because the options require us to match B1 and A1, B2 and A2, B3 and A3. So we already have B1 and A1. I can replace or I can divide this equation with A3. So I will have B1 by A1 minus 2 B2 A2 upon A1 A3 plus B3 upon A3. That is 0. So we have matched B1 and A1, we have matched B3 and A3. We are stuck here. So what can be done here? So if we go by the symmetry, we should have B2 and A2 here. So let us try to replace A1 and A3 with something. Because A1, A2 and A3, they all are in GP. So I can say A1 into A3 is A2 square. So that information can also be used. So A1 and A3, they can be replaced with A2 square. So what we'll have is B1 by A1 minus 2 B2 A2 upon A2 square plus B3 by A3. And that should be 0. We can cancel A2 with A2. So finally what we have B1 by A1 minus 2 B2 by A2 plus B3 by A3, that is 0. So this is similar to, or this can be written as B1 by A1 plus B3 by A3, that is equal to 2 times B2 by A2. Now that is equal to P plus R is equal to 2Q. If that happens, then we can say that P, Q and R, they are in AP. So similarly, we can conclude here that B1 by A1, B2 by A2, B3 by A3, they are in AP. So if that is the conclusion, then the answer will be option C.